Hello everyone, good afternoon. My name is Praveen Sharma. My student ID is PN 1037540, and today I will demonstrate my master's final thesis that I am pursuing in data science. The title of my research paper is An Ensemble of CNN Models with Fuzzy Rank Dependence for Classifying Cervical Cytology. Let's start with the introduction section of my paper. As we all know, cervical cancer is the fourth most common category of cancer in women, affecting more than 0.5 million women worldwide and causing more than 0.3 million deaths annually. Hence, early detection is crucial for preventing and curing the cancer. The primary limitation in the diagnosis of cervical cancer is the complex and the time-consuming detection procedure, besides the subjective variability in the screening process, which may lead to fatal error in the diagnosis. So the researchers have been trying to develop many automated computer-aided diagnosis methods for the fast, sensitive and accurate detection of cervical cancer, which can augment the success of pathologists and doctors in cancer diagnosis and prevention. In this research paper, we have used deep learning, and within that we have used the Ensemble process. So we all know deep learning is an important tool of artificial intelligence that has been prevalent in formulating decision support system for biomedical image classification. However, end-to-end classification using deep learning models requires a lot of training data to provide satisfactory performance, which is often not available in medical domain due to various limitations, because these are the very complex organs and taking the images might take time, and also the quality is not that good. Moving further ahead, let's talk about the problem statement of my research paper. As we all know, cervical cancer is a significant global health problem, particularly in the developing countries where access to screening program is limited. Automated cervical cytology classification systems using deep learning algorithms have demonstrated significant potential in improving the accuracy of cervical cancer screening. However, these algorithms often suffer from issues such as variability, interpretability, and bias, which can limit their effectiveness in real-world settings. Therefore, there is a need for a robust and interpretable approach to cervical cytology classification that addresses these challenges and can be applied to diverse populations and settings. The problem statement for this research paper is to develop and validate the suggested ensemble of CNN models with fuzzy rank dependence for cervical cytology classification that improves the accuracy, reliability, and interpretability of cervical cancer screening while addressing issues of variability, bias, and efficiency. This research paper will also solve some issues, like it also comes with some benefits. Moving ahead, we will talk about the aims and objective of this research paper. We are trying to achieve 4 aims with this research paper. The first one is to develop an ensemble of CNN model with fuzzy rank dependence for classifying cervical cytology images. The ensemble method will use a fuzzy rank based aggregation function to combine the output of multiple models, each trained on different subset of the dataset, to produce a more robust and generalizable classification model. The second aim will be to evaluate the performance of the proposed method on a dataset of cervical cytology images. And the dataset will include images from patients with varying degree of abnormality, including normal, low-grade and high-grade abnormalities. The third objective is to compare the interpretability of the proposed method with the other state-of-art methods. The interpretability will be assessed by analyzing the contribution of each feature to the classification decision, which will provide insights into the decision-making process. And finally, to investigate the potential impact of the proposed method on cervical cancer screening programs. This fourth objective is to study the potential impact of the proposed method on cervical cancer screening programs. Now we will talk about the literature review section. In recent years, there has been significant increase in the use of machine learning techniques, particularly CNN models for medical image classification tasks. The literature review identifies the gaps and limitations of existing techniques and highlights the potential of the suggested fuzzy rank based ensemble of CNN model. This section begins by discussing the various techniques used for cervical cancer diagnosis, such as pap smear and human papillovirus testing. It then reviews the use of medical imaging techniques such as colposcopy and digital cervicography for identifying cervical cancer. The literature review highlights the limitation of these techniques, such as subjectivity of the interpretation and need for trained medical professionals. The section then reviews the use of machine learning techniques for medical image classification, particularly the use of CNN models. It discusses the various architecture of CNN models and then their application in medical imaging. The literature review identifies the limitation of existing techniques, such as lack of interpretability and the need of large data sets. In addition to discussing the existing research on cervical cancer diagnosis and medical image classification, the literature review section of the research paper also aims to provide a theoretical foundation for the suggested ensemble of CNN model with fuzzy rank dependence. The section discusses the concept of fuzzy set theory, which is a mathematical framework for dealing with uncertainty and imprecision. The section also explored the use of fuzzy logic in decision-making process, which is particularly useful in medical diagnosis, where there is often a degree of uncertainty. The literature review highlights the potential of fuzzy logic in medical image classification and the proposed use of fuzzy rank dependence to improve the accuracy and interpretability of CNN model. The section discusses the various methods used for fuzzy rank dependence, such as fuzzy ordinals regression and fuzzy rank aggregation. The section also discusses the benefits of using an ensemble of CNN model, which can improve the robustness and accuracy of the classification task. Overall, the literature review section of the research paper provides a thorough overview of the existing research on cervical cancer diagnosis and medical image classification, as well as theoretical foundation for the suggested ensemble of CNN model with fuzzy rank dependence. By identifying the gaps and limitation of existing techniques and highlighting the potential of the proposed model, the literature review section sets the stage for the subsequent section of the research paper. We will move to the next section, that is the methodology of this research paper. The research methodology used in this research paper involves the development of a fuzzy rank-based ensemble of convolution neural networks, models for the classification of cervical cytology images. The methodology includes several key steps, including data acquisition and pre-processing, model development and training, evaluation and comparison of results, and statistical analysis. The methodology starts with the acquisition of cervical cytology images from two publicly available datasets, Mendeley LBC and CyPECA MED. These datasets contain many images that have been annotated by experts with information on the presence or absence of abnormal cells. The images are pre-processed to enhance contrast and remove noise, and then split into training and testing sets. The next step is the development of the suggested ensemble of CNN model with fuzzy rank dependence. This involves the use of the multiple CNN models, each with different architecture and hyperparameter. Data trained on a training set of images. The output of each model is a probability score for the presence of abnormal cell in the image. The fuzzy rank based ensemble combines these probability score using a fuzzy rank aggregation method to obtain a final classification result. The methodology includes an evaluation of the performance of the fuzzy rank based ensemble of the CNN model using various performance metrics, including accuracy, sensitivity, specificity, and area under the curve receiver operating characteristic curve AUC ROC. The results are compared with those of the individual CNN models and other state-of-art methods for cervical cytology classification. Finally, the methodology includes statistical analysis to determine the significance of the difference between the performance metrics of the fuzzy rank based ensemble and the other methods. This involves the use of statistical tests such as t-test and ANOVA test to determine whether the differences are statistically significant or not. In the next slide, we will see the graphs and the diagrams for this methodology. So on the screen we can see two images. So the first one, it says that through the Inception V3 model architecture, we are trying to create a base learner, and we are providing the input parameters, and at the end we are trying to get the output. So we can see 5x, 4x and 2x formulation we have selected. And coming to next, the exception model design for the base learner 2. This is the exception model that we have used, and within that point voice convolution is used. On the right hand side images, you can see a fully functional end-to-end description of our model. So on the first attempt we have cytology images, cytology test is done, then we have received input images. Now we have the base classifiers, DenseNet 169, exception and inception v3. Inception v3 and exception we have already talked on the left image, and DenseNet is also there. Now the images is processed through base classifier, and there all the missing images, everything is sorted, and after the base classifiers we move to the ensemble process, which is the important part where we have worked. The rank based fusion is done, and using the formula mentioned in the snapshot, and at the end, like once the image is sent to ensemble and the output of this ensemble is the final prediction, where the system identifies that based on the input image what is the predicted category that the risk of the participant lies, that is whether it's a superficial intermediate, or it's a parabasal, or it's a metaplastic, or choleocytic, or dyskaryotic. So this way this ensemble method using rank based fusion help us in better identifying the image and identifying the final prediction. Now as we have seen the methodology section, we will move ahead for the results and discussion section. So in this we have firstly distribution of the class in the data set is discussed, and noted that most of the sample belong to the negative class, which may lead to the class imbalance. After that, the confusion matrix and classification report was generated, and that was all generated after training the fuzzy rank based ensemble process. And this leads to the following findings: that the overall accuracy of the model is high, but it also highlights that it is very important to examine the precision and recall values of each class. To further analyze the performance of the model, a receiver operating characteristics ROC curve is generated, and the area under the curve, that is AUC, is calculated for each class. This leads to the finding that the AUC value are high for both class, indicating that the model is effective at distinguishing between positive and negative samples. Also, we have done feature visualization using the grad cam technique to visualize which area of the image the model is focusing on when making its classification decision. This leads to the following result: that model tends to focus on the nuclei of the cells, which is a relevant feature for distinguishing between abnormal and normal cells in cervical cytology. And finally, the model is evaluated further, and it is based on accuracy, F1 score, AOC, that is area under the receiver, and ROC, and the results show that the SMART method performed the best, followed by the CBOS, Addison, Ross, and Russ. The SMART method showed the highest accuracy, F1 score, and AOC values, and we can see this result in the coming slides. So we can see on the left side the formulas for the precision recall and F1 score that was used for the calculation, and on the right side we can see for the data set CIPCA-MET 2 class, 5 class, and Mendeley LBC. The folds, the number of folds that we have targeted is still 3 folds, and we can see that the accuracy, precision, F1 score, also we can see the recall percentage, and in the Mendeley LBC we can see the average standard deviation, that was 99.45, we had 23 and 0.21, it is around 99.45%, and the precision is 0.994, and so on. We'll move to the next slide for more discussion. So in the discussion section we can see that we have an image, it's about the true positive and false positive on all the three two data sets. First is CIPCA-MET 2 class, CIPCA-MET 5 class, and LBC, and this shows the thorough, the total false positive and true positive for entire 2 data sets. We'll move to the next slide for further discussion. So the previous data that we have explained, it was on the training data set, and on the validation data set we have analyzed that the overall accuracy was 98.04%, which is higher than the accuracy achieved by individual CNN models. The fuzzy ranking approach helped in improving the classification performance by considering the uncertainty associated with prediction of different CNN models. And also the oversampling helped in improving the classification performance by balancing the class and generating more samples for the minority class. This article also goes on to analyze the finding of the validation testing and explains why the ensemble of the fuzzy rank based CNN model performed better than the individual CNN models and other cutting-edge techniques. According to the study, the combining of CNN model with the fuzzy rank based ensemble technique, which lowers the bias and variance in the prediction, is responsible for the enhanced performance. Now we will move to the conclusion. Coming to the conclusion of this topic, this section summarizes the key findings and outcome of the study as well as provide recommendations for future research. The study begins by summarizing the results and highlighting that the suggested ensemble of CNN model with fuzzy rank dependence achieved higher accuracy and AUC compared to individual CNN models. This paper then addressed that how its finding may be interpreted. In the paper opinion, the suggested technique might be utilized as a diagnostic tool to help medical professionals spot aberrant cervical cells, possibly resulting in early detection and identification along with treatment of cervical cancer. Overall, the study concludes that the suggested ensemble of CNN model with fuzzy rank dependence has the potential to be a valuable tool for cervical cancer diagnosis, and further research in this area could have significant clinical implications. We also have some future recommendations. One of the recommendations is to explore the effectiveness of using different ensemble methods such as bagging or boosting in conjunction with the fuzzy rank based approach. Furthermore, the study focused on classifying cervical cytology images from a single dataset, and thus it would be interesting to evaluate the generalizability of the proposed methods on different datasets with varying characteristics. As you know, we have used this on publicly available dataset. If we can use it on some private datasets and then we can compare the diagnostic test and the results, then it will be really beneficial and it will be another area of work. Finally, the study used only one type of pre-processing method for the image data, and thus exploring different pre-processing techniques could potentially improve the classification performance of the proposed method. Overall, these future recommendations can serve as a starting point for further research in the field of cervical cytology classification using deep learning techniques. And lastly, I would like to thank my LJMU faculties for providing me assistance and guidance wherever I was stuck and helping me. My thesis supervisor helped me a lot in finalizing my research topic, and also she provided various comments which I implemented in order to complete my final thesis. Thank you.